Before, please give yourself a score out of 4. Here you go. So number 1, I think, should be 26. Number 2 is graphed there. Off to the right. Number 3, y equals negative 1/4 x plus 2. Number 4 is factored there. So this is where you're looking. Please, for goodness sake, like that. 4 out of 4. 4 out of 4? Yes. Okay, so we're looking at these. We're getting ourselves a score real quick. Hey, I got 2 out of 4, 1 out of 4, 3 out of 4, whatever it happens to be. And then I would encourage you at some point, whether it's here in class or maybe tonight, look through this last week and say, look at my scores. They went 4, 3, 4, or 2, 3, 4, or 1, 2, 3, or 1, 2, 2, or hopefully not 4, 3, 1, right? Hopefully that's not the case. But just pay attention to the trend. Question? Okay, here's number 3. I'm going to show you to the same way. I'm going to ask you the same questions. You guys could quiet down, please. Just want to make sure that I'm heard as best I can. Okay, so if you're going to write the equation or graph of a line, you need 2 things. What are they?
Points.
That's right. And of those 2 things, which one did you just get for free?
Point.
It's right there, isn't it? The point. So, point slope form is what we always start off with, because if you have a point and a slope, you use point slope form. I hope that makes sense. So I'm going to write y minus 5 equals blank times x minus negative 12. Now I've got a blank there because my slope needs to go where that blank is. And I don't know what it is. I don't know what the slope is yet, but I'm about to figure it out. So I'm not told really anything about my slope other than my line is perpendicular to this other line. So what's the relationship between perpendicular lines? Say again? Ooh, this is a really crucial point. Yeah, reciprocal and opposite. So reciprocal means you flip it. Opposite means you change the sign, right? So what's the slope of that red line that I have highlighted up there?
4.
The slope is 4. So the reciprocal of 4 is 1/4, and its opposite is negative 1/4. Yeah. So now I know what my slope is. It's right there. So really, to be honest with you, that's a really good equation of the line. It's just that the question said, please put it in slope-intercept form. So, Sebastian, what do you think would be a good first step to get this into slope-intercept form? I kind of disagree. I think that clutters up the right side a little bit.
Okay.
You couldn't do it that way. I think I would distribute, right? Because you have that 5 over there, and you're like, well, do I add the 5 to the 12? I don't know. And it gets all cluttered and messy. But I think if you distribute here, it's less cluttered and messy. So this would give me y minus 5 equals negative 1/4 x. And then, I don't know, probably maybe I should slow down here. Do you know what negative 1/4 times 12 is?
No.
So
Negative 3.
So it's negative 3.
Okay.
Basically, 1/4 times 12 is the same thing as 12 divided by 4,
Okay.
which of course is 3, right? So I'd go minus 3. And my final step is where I would add that 5 over, like you suggested, because we do need to do that, of course. So I'd go y equals negative 1/4 x. Negative 3 plus 5 is, there's your plus 2.
Okay. Thank you.
Okay. And you said number 4. So with number 4, it says factor completely. I'm just gonna keep asking this question. When you go to factor something, anything, whatever it happens to be, what should you always consider first when it comes to factoring? That's right. And what's the GCF on this one? It's a 1 technically, right? But we wouldn't even really count that as a GCF. So we'll say there's not really a GCF. So if there's not a GCF, my next step, my next decision is to say, all right, how many terms are there? Is it a binomial or a trinomial? It's a trinomial, right? Sebastian, does that make sense?
Yeah.
Okay, and then how do we factor trinomials with 3 terms?
You do.
Yeah, Anya's given me this hand motion. What is she trying to say? You do the X box thing, right? So that's correct. So my A is 12. My b is negative 5. Oliver, are you following this? This is the thing we were talking about a second ago. So Oliver, please, hey, make sure that this is super solid. Okay, so then Sebastian, do you know what goes in top of the x? No. No. Sorry. It's not A. I'm asking Sebastian what goes up here on the top. It's not A, it's not B, it's A times C is correct, Bree. So, Sebastian, A times C is negative 24. What goes in the very bottom of the box, or of the X, excuse me? No? What goes in the bottom of the box, or the X? Negative 5. Hey, this might, can I take a pause here? I want you guys to hear something. Hear me really well here. Nobody in this class has ever asked me this. So why don't I ask myself this? Hey, Mr. Anderson, if you were going to factor number 4, would you use this X box method? Anybody curious about that answer? Yes. Hey, Mr. Anderson, would you use this method that you're showing everyone to do this? The answer is no, I would not. You want to know the answer I use, the method I use? Very educated guess and check. Honestly, can I just show you real quick? And there's a point to this. So what I would do, I'll do this in red. I would look at this and I would say, I know it's got to be a binomial times a binomial. I know my last term has to be negative 2. I know my first term has to be 12x squared. And I start to think, okay, how do I make a 12? I get to do a 1 times 12, a 2 times 6, or a 3 times 4. And I start to think, well, how do I get the 3 times 4 to work with the negative 2 to be a negative 5? And I think to myself, well, 4 times 2 is 8, and 3 times 1 is 3, and 8 minus 3 is 5. And I start to think, oh, okay, so I'm going to go 3x here, I'm going to go 4x here, and let's see here. I need this to be a minus 2 because that'll get me to negative x. I need this to be a plus 1. That'll get me to 3x, and I'm done. Here's my point. I can do it that way because I've multiplied for more years than you were even a thought. That makes sense? Like before your parents thought, hey, maybe we should have a baby. Maybe we should have another baby. I was doing this for like 5 years before you were even a thought. Here's my point. If I were to say, hey guys, my method for you is guess and check. Just do some guessing and checking, guessing and checking, guessing and checking. Can you imagine that would go over pretty poorly? If I just said, hey guys, start guessing and checking, you could guess and check for the next 5 years and you may or may not get it. So here's my point. In lieu of me trying to just get you to guess and check, I'm giving you a tried and true system that works. But the system doesn't work at all if you don't focus on the details, right? When you look up at that X, if all you see is, man, I just got to throw some numbers in there and I don't remember which one is which, and you don't really narrow in on the details and say, the top is always A times C. The bottom is always B. If you don't really buy into that, your technique's going to stink, right? Because it doesn't really matter what numbers you put in there. If you put the wrong numbers in, it's not going to work. So when I say, hey, what goes in the top? And I'm kind of greeted with, I don't know. And then Anya shouts out, AC, or, Bree was like, it's AC. And then Anya's like, it's a B down there. Like, if there's only like 2 or 3 of you that are bought in, this system won't work. And there's a lot of systems. Did you know? There's another system called the Super Magic X. There's another one called the Magic X. There's another one called the Berry method. There's another one called Bottoms Up. There's this Xbox method. There's so many methods. Listen, none of them will work if you don't focus on the details. Okay? So Sebastian, I think this is it. Like when you look at this, you say, man, I'm struggling with number 4. I don't know what to do. I'm giving you the recipe right now. The recipe is not, hey, do it like me and just guess and check. I don't think it's going to work very well. The message I would get to you is make sure you get the details right. Okay? So AC goes in the top, B goes in the bottom. Now there's a number of ways to get the other 2 numbers, but bottom line is this. We're looking for the numbers that multiply to be the top and add to be the bottom. here'd be my suggestion. If you look at this and you're just like, Mr. Anderson, I got nothing. I am so clueless. I don't know how to do this. You should use your calculator. Here's what I would do. I'm going to erase this in a second. If I were you and I just felt like, honestly, like if I was doing one of these with bigger numbers and I was like trying to do it in my head, I'd probably get out my calculator and say, well, gosh, what do I need to multiply by to get like 1,076? I don't know. I better start doing some work like this. Here's what I would do. I would just go, on my calculator, I'd go negative 24. Negative 24 divided by 1 equals negative 24. Do these two numbers add up to be negative 5? So that's out. Then I would go on my calculator, negative 24 divided by 2, and it would tell me negative 12. Do these two numbers add up to be negative 5? They do not. So you know what that means? I keep going. And then I would say, well, the next number is 3. Negative 24 divided by 3 is negative 8. I would ask myself, does this number here plus that number there equal negative 5? I found it. So instead of just staring at it and saying, I never learned my multiplication tables, I don't know what to do, get your calculator out and just start dividing and seeing what happens. Explore it and try it and see, can I figure this thing out?
Okay.
This works now, right? Okay. So I take all that work off my calculator and I put a positive 3 and a negative 8 right there. And I've got all my numbers ready to drop into my box. So I come over here. So again, this is part of the system. So you just gotta know how to work this system. Because frankly, the alternative is one of the other methods. And if you don't pay attention to the details on this, then the other methods won't work either. And the other alternative is guess and check, which I'm guessing won't go that well either. So Sebastian, do you remember what goes in the upper left-hand box? Not just a, but ax squared, right? Yeah, 12x squared. What goes in the lower right box?
Negative 2.
That's right. And what about the two diagonals that are blank right now?
The top right one is 3x, and the bottom one is negative 8x.
Okay, so here's my assessment. I think you absolutely know how to fill in the box, but you don't know how to do the x part. You're good at the box, but not the x. So focus on the x part. AC in the top, B in the bottom. Use your calculator to get the other two.
Okay.
Okay, so now what we do is we factor along the red arrow. What's the GCF on the red arrow?
1.
It's just a 1, right? Yeah, it's a positive 1 specifically. What is, then Sebastian, I want to hear you say this one.
Mm-hmm.
What's the GCF along the green arrow?
Oh, no.
12 is not divisible by 8.
Oh, no, just x.
So there is an x in common, but there is more. What goes into both 8 and 12?
1.
4, right?
Yeah.
8 divided by 4 is 2, 12 divided by 4 is 3. Alrighty. So what about along this blue arrow? What's the GCF there? Negative 2, right? We finished with a negative box, so we factor out the negative. And how about that
3x.
final box there with nothing? It is a 3 and an x, so 3x. So there you can see your final factors, 4x plus 1, 3x minus 2, and you're good. The details are everything, right?
Yeah.
Put numbers where we want, but it's not going to matter if they're not the right numbers. Okay. You got 3 out of 4, not 3 out of 5.
No, I got the graph wrong with the.
Oh, you gave yourself 2 points possible for number 2. It's all or nothing on number 2, my friend. All or nothing. Okay, anybody else? Nobody else asking? Man, I really hope that tomorrow is your best. Yeah, I hope that you've been getting 2s and 3s and 4s all week, and tomorrow's going to be a 4. What could you do?
Go back through your weekend.
Yes, I can tell you've been listening. That's great. Because I'm thinking about you tonight at like 6 p.m. You're thinking, all right, what's my day like tomorrow? You're thinking, oh yeah, DMR quiz in math tomorrow. I want to make sure I do well. You go back and retry. I'm making a video right now. There's all kinds of resources for you. There's no good reason tomorrow can't be your best day of the week. And hopefully that's a 3 or a 4. Hopefully a 4. Okay. Hey, grab your computers. We are going to do a little Desmos. I'm super excited about this today. Should be really fun.
Is this the last thing we're going to do in class?
We'll probably do a little exit ticket with maybe one example or something. This will be a pretty good long. This will be a long Desmos today, actually. YV6 63T this is going to seem weird at first, this is very geometric. Very geometry-like. But it is algebra, I promise. But it does seem very geometry-oriented. I hope you have fun with this. It's about something called complete the square.
My name is
Oh no, what? Like literally all you're going to be doing here for a while is taking something that's not a square and making it a square. Honestly. Trevor. I don't know. This often doesn't work that well with a phone. You can try it if you want. But most of the time, you'll get some slides that work pretty well and others where it's just like, it doesn't work well. So hopefully it works for you. How many x's do you have? So I'm thinking that first one would be x squared plus 4x. That's it.
Oh, I thought it was like, what is it, like addition, like multiplication?
Yeah, you have one x squared tile or little. These are, I don't know if you've ever done anything called algebra tiles. That's really what these are. Just virtual ones. Okay, so there's the code in case you're a little slow getting on. I want to start looking at what you guys are putting. Okay, so Julia, maybe not done with slide 1. Sophia, I would say replace your equal sign with a plus and we're in business. Oliver, that looks good. Sebastian, if you add up 4 x's, you do not get x to the 4th. Think about what x plus x plus x plus x is. It's, 4x. Anya, that looks good. Ella, that looks good. Rar is not done anything yet. Bree, that looks good. I'm just looking at slide 1. Kate, that looks good. Ellie, remember, x plus x plus x plus x is not x to the 4th. It's 4x. Caroline, maybe not done yet. X squared. Mason, the only thing there is it should be x squared. Mason should be plus, not times.
Wait, no. 4x. No, all of that is.
Guys, you
number 2 is times. It's my bad.
Number 1, we got to get this right. Noah, it should be x squared plus.
Plus x squared?
Plus.
That'd be just
Noah, did you hear me?
Yeah, pop, because this is another one.
Trevor, there's no e involved on this one.
Wait, Mr. Anderson, is this like, so these are 2x, like that's 2x, 2x.
Yeah.
Squared? Is it multiplication, like all of that?
No, it's always it's plus.
Addition.
If
So
it-
then it'd be like 5x squared. Then, correct?
No. X squared plus 4x, those are unlike terms.
Oh, I thought they were 4x squared, never mind, sorry.
Those are just x's. Yeah. So Mason, I do want you to fix slide 1. I don't know where you are right now.
On slide 4.
Oh goodness. If you go super fast and Mason, if you go super fast and get them all wrong, there's no point.
I think it's
Wait, on the left.
Okay, slide 1 should be x squared plus 4x. Looks like most of us are getting there. Mason, if you want, you can use the caret button to get a exponent. So if you want to type in,
It's fine. I like typing.
No, like carrot. I'm like, shit. But you need to do an exercise.
I can type X who do though. Yeah, you do.
well, we can only give you advice and choose not to do. So that's like if somebody said, "Hey, is that a square?" Is that a square? Is that a square? Like this whole shape? It's definitely not a square, right? We're missing a chunk of it right there. So this is kind of the point. I want you to like play with this and discover it, because if all I do is just like tell you the answer, it really honestly defeats the purpose of this. So I want you to try and succeed or try and fail, and then we'll start to like guide you a little bit. Okay? By we, I mean all of us. Yes.
Is it like complete, like just this side, like the whole square?
No, do you not see
The whole shape. There's a chunk taken out of the bottom right.
Oh, that's incorrect. 2x is incorrect.
I hate Kaiba's movements.
Actually, it might be 2x
Okay, Trevor. I'm looking on slide 2 now. Trevor, slide 2 should be x squared plus 4x. Right? Because there's 4 x's and there's 1 x. Okay, that's the issue is the phone. Hey, so Noah, x squared plus 2x plus 2x, please look up there. Should be x squared plus 4x, right?
I have x squared plus 4.
Oh, now it is. There we go. Doc Stanley, there we go. Mason, once again, it should be x squared plus 4x. Caroline looks good. Ellie looks good. Kate looks good. Bree also good. Ella, that's good. Anya, that's good. Sebastian, everybody. Oliver, you're getting it. Sophia, Julia. Okay. Let me look at slide 3. See if anybody's got it. Oh, Sebastian. Hey, you guys should be looking at the screen up there. How many unit tiles are needed to complete the square? He said 4 of them. Yes. Ella, 4. Good. Bree got 4. I don't know if you guys are putting them in now, but Ellie.
I had 4x.
Caroline. Bree, you had 4x? Oh.
I had 4x.
So, hey, guys, hey. Everybody. Let me this will help you a lot. Please, eyes on screen. If you're looking at me, you're looking at the wrong thing unless you're, I don't know, whatever. You do what you need to do. So, this, please, everyone, look up there. This will maybe clarify why what Sebastian put is good. If that blue square is x squared, doesn't that mean that this right here is x long, and this up here is also x long? Isn't the area of a square just side times side? Okay, so if the blue square has an area of x squared, that means it's x times x. Wouldn't that mean that this dimension right here, doesn't this also have to be x?
Yeah.
Okay, now keep following. Doesn't that mean then if the green, please pay attention, if the green rectangle has an area of x, what's the other dimension on the green rectangle? No, because if this is also an x, wouldn't the area be x squared?
Yeah.
So in order for that area to truly be x, here we'll do this, what would this dimension have to be? Come on, what's the area of a rectangle? Base times height. So, hey, you guys know how I say it all the time? I say, I'm not trying to appeal to like making you follow rules. I'm trying to appeal to your logic. Hey, listen. Anya, this way. I need to know that you're all focused. If a rectangle has an area of x and the height is x, what's the base? No, because x times x is x squared. Let me phrase it a different way. X times what is x? It's 1. Isn't x times 1 x? So wouldn't the orange dimension have to be 1? So if I was going to fill in this little blank spot, wouldn't these all have to be 1 by 1? How many of them do I need? According to Sebastian, it's 4. And do you see how he's right? Trevor, what's going on with the phone? Is it going okay? Okay, earlier you said it wouldn't load and all that stuff. Okay. Okay, cool. Are you guys with Sebastian on this? Do you see it?
Yeah,
Okay.
You see best.
Let's go.
Okay. Let's see what...
What's this square?
Oh, look at that on the next screen. Do you see it?
Yeah.
Yeah.
Okay, so let's see what you guys think about. I haven't seen anybody answer this one yet. Ella, that's not right. How many unit tiles did we add?
4.
According to this, you're saying we need to add 2. Do you see why that's wrong? And I would say the 2x and the 2x would add up to be, oh, it's not 2x times 2x. It's 2x plus 2x. Everything gets added on these algebra tiles. Everything gets added.
Wait, so
Let's see what everybody else has.
write the area of the square, so that'd be base times height, right?
There are a lot of, oh man, you want to see something cool? Let me see if anybody's got a right answer first. Sophia does. So, guys, I've said this before, I'll keep saying it. Eyes up here, please. Like up there. If you are not fully focused, you don't have a prayer. You will leave here feeling lost. If you are fully focused, you have a good chance. So, you just said, Anya, could we need to find the area. This might blow your mind. Check this out. I could find the area in 2 ways. Number 1, I could just add up all the stuff I see. So here we go. Area of x squared plus x plus x plus x plus x plus 1 plus 1 plus 1 plus 1. Right? Then this is not the mind-blowing part yet. How many x's are there?
4.
How many 1s are there? There's your area. Let's do this a different way. Can't you find the area of a square by multiplying the base times the height? Okay, think back to your geometry you learned in middle school. Don't you go base times height? So, how long is the base? Oops, I missed.
2x.
No, it is not. The base is x plus 2. This is x long. This is 2 long. If something is x long, think about it. Just, again, use logic. I'm not asking you to use anything other than logic. If one piece is x long and the other piece is 2 long, how long is the whole thing? X plus 2. How long is this dimension up here?
X plus 2.
That's also x plus 2. So, base times height, check this out. Base times height would be x plus 2 times x plus 2,
X plus 2.
which is x plus 2 squared. And I could use my boxes to do this. X plus 2, x plus 2. What's x times x? X times 2?
2x.
2 times x.
2x.
2 times 2.
4.
Do you see it?
Oh.
X squared plus, aren't these like terms? So it works either way. It works either way. Okay, I'd really like for you guys to get a little further than just slide 4. What's that? If you must. Okay. Hey, skip ahead to slide 6. If you're jacking around on slides 4 and 5 right now, please go to slide 6. This is where we're going to try the same thing again. Let's see how you do on slide 6. Okay, let me slide through some answers here. Okay, Julia, looks good. Sophia, good. Oliver, keep going. Sebastian, good. Anya, good. Ella, good. Bree, keep going. Kate, good. Ellie, keep going. Caroline, good. Mason, good.
Yeah.
Noah, good. Trevor, also good.
Mason. Yes, sir.
Slide 6 should be x squared plus 8x. Okay, please try slide 7 once you've done slide 6. Focus, please. Here we go. Julia, waiting on you. Sophia looks good. Oliver, waiting on you. Sebastian, Anya looks good. Ella, good. Mason should not be x to the, or Bree should not be x to the 6th. Should be x squared. Kate looks good. Ellie, also good. Caroline, good. Mason, add 4. You didn't really read the instructions. Sorry. Doc, correct. Trevor, keep going. Noah, keep going. We're on slide 7, Noah. Once you're done with slide 7, please go to slide 8. This is where you get a chance to complete the square again.
It's easy. It's add 4.
Okay, Noah. Trevor and Noah, I'm still really waiting on you guys. You guys are way behind us. We're on slides 7 and 8 right now. Doc, that makes sense. Good job on slide 8. Mason, slide 8's not correct. I'm sorry. Caroline's good. Ellie, good. Looking at slide 8. Ella, looks good. Anya, looks good. Sebastian, yes. Oliver, good. Sophia, good. 16 for slide 8. So, do you see how the square is complete? Please move on to slide 11.
Are you kidding me?
So slide 11.
Where'd you get on 9?
We've taken way too long on the first couple slides. I had to do a lot more teaching than I anticipated. So I'm skipping. I'm trying to get to a place where you're in a good spot. Okay? So please take a look at slide 11. Slide 11 is just like the other ones we've been doing, except it's a little more compressed. It says, how many unit tiles are needed to complete the square? Let's see what you all have to say. So Sebastian, we're just looking for a number here, not an expression. Oh, here we go. Noah, yeah, again, Noah, we're simply looking for the number of squares needed. Trevor, 10 is not correct, I'm sorry. Whoa, Doc, you got it. Good job.
What?
Ellie, that's not right, I'm sorry.
Is that right? Check Mason Rock.
Still looking for Mason. Julia, that's good. Anya, oh, yeah, I'm just catching you in the middle of typing. Anya and Ella, that's good. Kate, there we go. Ellie, Caroline, 10 is incorrect, I'm sorry. Maybe this will help. Check it out. Here's the blue square. And the green rectangles would be like this and this. How could you complete the square? How many units do you need? Don't you just need a 1 by 1? We just need this yellowy orangey one, right? So 1 unit. Let's keep rolling. Guys, will you please try slide 12? Very similar. Come on, slide 12. You can do this. Slide 12. Rearrange it like I just did if you need to, but let's think about how many units, tiles do you need? Let's look and see what you put. Noah and Trevor waiting on you. Doc, 3 is not correct, I'm sorry to say. Mason, 2 is not correct. Caroline, correct. Ellie, sorry, not correct. Kate, Bree, good. Ella, sorry, it's not 2. Sebastian, you got it. Oliver, you got it. Sophia got it. Julia got it. Yay. Hey, listen up, please. Here's how this works. Here's the blue square. Here are the green rectangles. There's 1 of them there, 2 of them there, 3 of them there. 1, 2, Oh boy. 3. So what do I need? This is hard to draw, but I'm doing my best. You need 1, 2, 3, 4, 5, 6, 7, 8. Do you see how 9 complete the square? 9 of them. So Julia and others, great job. I think there's one more. Look at slide 13.
Slide 14.
Slide 14, please.
So I have 13 or 14?
13.
You just said 14.
13.
So like,
What a weird thing to argue about. I'm telling you it's 13. Let's see what you all think about slide 13. Ooh, Sophia, good. Oliver, good. Anya, correct. Bree is correct. So is Kate. So is Ellie. Caroline, I'm sorry, it's not 10. Mason got it. Doc got it. Noah, it's not 5. Sorry, Trevor. Good.
Sorry, Trevor.
yeah, I don't know.
Hey, guys. Hey. Shh. I need to feel like I've got your full attention here to make this point here at the end. Let's go back to this one. This is slide 12. Hey, listen. The correct answer, we see Doc's up there. Correct answer is 9. I want you to think about something. This is going to be the thing I'm going to leave you with, and we'll practice this tomorrow.
Okay.
No, do not pack up. Just sit and listen, and I'll wait. I'm going to wait until you're not packing up. How many green rectangles are there? Gentlemen,
6.
Bray, Noah,
6 green squares.
it's not going to work if you're not paying attention. How many green rectangles?
6.
What is half of 6?
3.
Square that.
9.
I said
9 is correct. Now, you have to, no, don't go anywhere yet. You have to square it. Check out. Guys, please don't pack up. Mason, you haven't stopped. I'll take the time that I feel like I need. You did not follow my directions. Let's keep going. How many green tiles are there on this one?
10.
What's half of 10?
5.
Squared?
25.
Let me go back one. How many green tiles?
2.
Half that.
1.
Square it.
1.
See if there's one more here. How many green tiles would there be for this?
6.
Half it.
3.
Square it.
9.
9 would be, hold on, that's how you would complete the square. Check this one out. How many green tiles would there be?
4.
Half it. 2. Square it.
4.
Don't pack up yet, please. Ooh, this will be interesting. How many green tiles would there have been on this one? 24. Half it?
12.
Square it.
144.
You'd need to draw 144 of those. That's crazy. Last one right here. How many green rectangles would there be? Half it?
9.
Square it.
81.
If you can do that, you'll be successful tomorrow. Have a good rest of your day.
Mr. Anderson, I will be here tomorrow. And can I just make up the tomorrow on Seder connection?
Yes.
Okay.